All right. So with this, inequality notation looks like this. We use inequality symbols. We always use an X with inequalities. Always use an X with inequalities. So X less than or equal to 5. That's every number from 5 all the way to negative infinity. We do not actually have to use infinity and negative infinity with inequalities because X less than or equal to 5 kind of includes the negative infinity. Looking at a graph, we're going to use an open circle or a closed circle. We're going to connect the two circles, or we're going to draw an arrow, like maybe we're going all the way to the left. So we would draw an arrow representing that. Words, we can use words. The real number is greater than 6 and less than or equal to 9. We can talk about that. All of those you've probably seen before at some point. You've probably seen this one, and maybe it was a little bit confusing, this interval notation here. When we talk about interval notation, it's the same as all the other stuff. It's just a nicer way to write it, I guess. We don't need X's. We don't need inequality symbols. It's just a nicer way to write it, I feel like. But it is kind of confusing. And why does it get confusing? It gets confusing with whether we include the boundary number or we exclude the boundary number. If we're including the boundary number, we're going to use a closed circle. So -2 to 4. That means all the numbers from -2 to 4, including -2, and also including 4. And then with the interval notation, a closed dot is the same as a bracket. So if you have a number line that's got a closed dot on it, you're going to use a bracket. And then with inequality notation, we're going to use the equal to as well. So less than or equal to, or the greater than or equal to symbols. If we do not want to include the boundary number, like this graph here, it goes from 1 to 3. That means we could be like 1.1, but not 1. Like 1's not included. Like it has to be greater than 1, but it has to be less than 3. And 1 and 3 are not included. So we use open dots on the number line. We use parentheses with the interval notation, and we use just less than or just greater than with our inequalities. Two mistakes a lot of people make with interval notation. They try to use brackets with infinity. We technically don't know what infinity is, so we can't include it. Like infinity is never going to be included because you can never reach infinity. So never use brackets on infinity. And always put the smaller number on the left. We do not want the smallest number on the right. You always want to put the smaller number on the left side. The bigger number always goes on the right side. So don't make that mistake either. So we have an inequality in our first example here. -2 is less than X is less than or equal to 3. And we want to just write this in the other 3 forms. So on a number line, what would this look like on a number line? We're just going to go from a number line. We're going to put -2 and 3 on our number line. I don't really care about any of the other numbers. If you want to go from like -10 to 10 or -5 to 5, I don't care about all that stuff. But as long as -2 and 3 are on our number line, we'll get what we need out of this. Since -2 does not have the equal to sign, so it's -2 strictly less than. That means the boundary point has been excluded. We're not including -2. So -2 is going to get an open circle. -2 gets an open circle. Is less than X is less than or equal to 3. Since it could be equal to 3, 3 is included, and 3 would get a closed dot. And at this point, we're looking at everything between those two numbers. Everything between those two numbers. So on our number line, we're just going to connect them. Maybe if you have a pencil, you would just shade it more darkly to represent everything between those two numbers. -2 not included because it's an open dot. 3 is included because it's a closed dot. So we could have numbers like -1.9. But numbers like -2, no, -2 is not part of that. In interval notation, we're going to write the smallest number, comma, the biggest number. Literally, the smallest number, comma, the biggest number. Interval notation is nice because we don't need all this other extra stuff. We don't need an X. We don't need inequality symbols. We just need the numbers, -2 and 3. And since -2 is not included, -2 is not included, open dot, parentheses. Open dot, parentheses. And since 3 is included, bracket. Close dot, bracket. Close dot, bracket. Those mean the same thing. Open dot, parentheses. Those mean the same thing. Close dot, bracket. Open dot, parentheses. And that goes back to what you see right above. And in words, if we wanted to put this in words, we might say something like the real numbers, because we're not talking about imaginary numbers here. The real numbers greater than -2. But at the same time, they have to be less than or equal to 3. So the real numbers that are greater than -2, not equal to, just greater than, but at the same time, less than or equal to +3.
Do we have to write the real number?
Do what?
Do we have to write the real number? Start off in grade.
Yeah, that's fine. Because when we start doing the problems that we're actually, this is more like review. Like you should have seen this at some point, but maybe you didn't. So let me go over it to make sure we know what it is. You're not going to use words anyway. We're going to use the other 3. So I'm not actually going to write any more of the words down. Example number 2, we have the integral -infinity to -2. -infinity to -2. -2 has a bracket. We need to know what that means. So on a number line, where would -infinity be? -infinity would be way over here on the left, +infinity way over here on the right, and -2 somewhere in the middle. You can put a bunch of other numbers on there too if you want. Would -2 get an open dot or a closed dot? Closed dot, good. And we're gonna draw an arrow. We're just gonna draw an arrow going to the left. So that would represent every single number less than or equal to -2. With inequality notation, we actually don't need to write infinity or -infinity. So we can just start with x and put -2 here. And we want every single number that is less than or equal to -2. So every single number less than or equal to -2. Number 3, we're given a graph, has an open dot. Open dot is at 1. We have an arrow pointing to the right. So in integral notation, we're starting at 1. That arrow going to the right represents infinity. Infinity always gets parentheses, because we can't reach infinity. So we can't put a bracket on it. What about 1? We would put parentheses, open dot, parentheses. That means we can get numbers like 1.1, 1.01, 1.0001. Like we can get really close to 1, but 1 is not actually included. So we use parentheses. And with our inequality notation, since we only have one number, we're going to put our x and our 1, and then we got to put our inequality symbol in this case. X is greater than 1, not equal to, just greater than. So any number that's greater than 1 would be included. But 1 is not. And we can put that in words if we wanted to. All right, the last example, we have Steve. Steve is at least, that's the key word there, at least 23 years old. So what does that mean? Could Steve be 23 years old? Or anything above it? So in interval notation, it would be 23 comma infinity. Obviously, he's not going to live to be infinity or like 5,000 years old, but we don't really know how old he's going to live. And if I just put 200 on there, we'd probably be safe that he's not going to live past 200. Probably could put 100 on there, but he might live past 100. We don't really know how long he's going to live. So let's just say infinity. And then the 23, since he could be 23, the 23 gets a bracket. So he could be 23. So 23 is included in our interval. And in inequality notation, x 23, in this case greater than, but he can also be 23. But we also need the equal to, greater than or equal to. And on a number line, 23 on the number line, closed dot or open dot. Closed, because he could be 23 or anything older than 23. Could be 23